Hi everybody, I'm Brian Croxall and this is my presentation for DH 2022. I'm grateful for the opportunity to record this because I missed my session earlier in this week because I calculated the time change wrong. And so I want to apologize to my fellow panelists and to the hosts of DH 2022. I'm grateful that they're making it possible for me to record this and upload it later. I'm looking forward to seeing everyone again, hopefully in Graz next year. But again, grateful that I can share this even though I apparently can't do math very well with time zones. So we'll go ahead and get started with the presentation. So my talk is called Good Grief, Encoding, Quantifying, and Analyzing Peanuts in the Classroom. So at the risk of stating the obvious, there's a lot going on in comics. Let me give you a few examples. Here we see Charlie Brown speaking to Schroeder about his piano playing. The strip starts with actual piano notation, which is fairly unusual. And this is, in fact, the music that Schroeder identifies later, where he names the piece not only in German, but in Fraktur. Schultz also signs his name in Fraktur. And Charlie Brown speaks a question mark. Is this a sound? Is it a typographic mark? How are we supposed to interpret this? Here's another example. We see Snoopy dictating to Woodstock, who often acts as his secretary. Now, Woodstock laughs here, but this is different from how he normally speaks, which is in these sort of slash marks. We also see Woodstock writing in shorthand. Are these real shorthand characters, or the equivalent of his hash mark speech rendered into shorthand? Then we've got the fact that if Woodstock almost always speaks in speech bubbles, but Snoopy, almost without exception, speaks in thought bubbles. And then when Snoopy kicks Woodstock, there's not only a sound, but also a visual effect. So again, a lot going on. But of course, if you don't look closely, each of these strips can be read in less than 10 seconds. So how can you teach students to look closely at comic strips? One method might be to introduce students to comic scholarship, like that of Scott McCloud's accessible classic, Understanding Comics, Hilary Schute's more recent Why Comics, or the audacious How to Read Nancy by Paul Karasik and Mark Newgarden. But another approach could be to have the students read closely through the act of encoding them. XML markup creates the opportunity to perform a closer than close reading as you work to be as descriptive as possible. And trying to be descriptive tends to lead you to start seeing things differently. What's more, once you've done enough specific encoding, you can begin to quantify and analyze some of the trends that you have found in the comics using digital humanities methods to consider comics at scale. In this presentation, I'll talk about just this, the close and distant readings of Peanuts in classes that I've taught for the last 3 years. I'll first discuss the process of encoding the comics and how my students and I have collectively determined what to encode and how to ensure consistency across semesters. I'll then discuss some of what we've been able to learn with our data. The class I'll be discussing is part of BYU's Digital Humanities and Technology minor. The class itself is called Research in Digital Humanities and is listed at the 300 level for undergraduates. You can probably imagine how popular a class with research in the title is. The point of the class is for students to learn and to deepen DH skills while doing original research. One way that this class could be structured would be for students to individually select a research project and carry it out over the course of the term. That seemed a little hard to ask of third-year students. Instead, I organized the class around one of my research projects. This means the students are engaged in original research, but aren't out there totally on their own. Instead, we work like a lab. When I started thinking about the class, I had at least 2 specific research questions in mind. Which characters co-occur with one another in the strip? And do the individual characters within Peanuts speak differently from one another in any marked way? The first of these questions is a problem of network analysis and requires knowing precisely which characters appear in each strip. The second is a question of stylometric analysis and requires having a complete record of each character's speech acts. Of course, to be able to answer these questions, we need good data. I had an idea of where we could get some of these data from the Go Comics website, which has a fully browsable archive of Peanut strips. With the help of my colleague Jeremy Brown, we scraped the website and obtained the data transcript, that's how it's labeled in the HTML, for each comic. But we quickly discovered there were problems with these. First, the transcripts were descriptive, and so there was a lot more text there than Schultz had actually provided. Second, there were abundant mistakes within them. And third, there were clearly different hands that had been engaged in the transcriptions, and they had not had a style guide to help them be consistent. So although this data was potentially still useful for a question of character co-occurrence, it was useless for stylometrics. We needed to have better data to answer all our questions, so I decided we would make our own. And this simultaneously helped the students develop DH skills and read comics more closely. To encode the comics, we drew on the work of John Walsh, who published the Comic Book Markup Language, or CBML, schema in 2012. CBML introduces new elements and recommends attributes and attribute values to accommodate features of comics that are not present in conventional print materials and therefore not in the standard TEI. CBML provides two new elements that we used for encoding Peanuts, the CBML panel and the CBML balloon. The first of these, the panel, allows us to specify an individual panel, including what characters appear within it, or, drawing on McLeod's work, specify the type of transition that happens between panels using the ANA attribute. I'll return to transitions later. The second of these, the CBML balloon, allows us to demarcate speech within comics, and we can use the who and type attributes to specify, respectively, the speaker and the shape and/or function of the speech balloon. What's more, CBML includes recommendations for how to encode other features of comics with existing TEI constructs. One example is using div type equals panel group to group CBML panel elements together. Each Peanut strip is encoded as a single div type panel group. We decided to then use the ANA attribute at this div level to encode aspects of the comic such as activities, settings, weather, visual features, and mentions of holidays. Building on Walsh's work meant first that we didn't have to come up with a schema from scratch, and second that our data is potentially interoperable with others' work. Ellie Milanis at Brown University assisted me by making a complete, valid XML document that incorporated CBML features that our class could use as a template. The template used a controlled vocabulary for many of its features, drawing from a separate taxonomy that we created. I added documentation as inline comments to clarify what goes in each portion of the template as the students worked. Providing a template meant that the students could spend less time on the nitty-gritty of TEI and more time looking really closely at strips and how they functioned. During the course of the term, my students and I read 2 volumes of the Complete Peanuts, which respectively covered 1950 to 52 and 1971 to 1972. Each student was assigned 2 months of strip to encode, and I took 3 months. While we worked independently, the encoding process was collaborative because looking closely at comics generates so many questions. For example, when do we encode snow as part of the weather? It seems self-evident that it should be recorded when it's actively snowing, falling from the sky. But what if it's just on the ground? Or what's the difference between McLeod's action-to-action and subject-to-subject transitions, numbers 2 and 3, once you start trying to apply them? What is the difference between, what makes something actually subject-to-subject? We had to collectively decide how to properly encode these, and countless other situations. This involved debating how comics work, which was one of the goals of the class, and it sometimes involved voting and being willing to concede a dispute. Since we had to make so many decisions, and since we knew this work would stretch across several semesters, we recorded the decisions in a style guide using Google Docs. It becomes the most important part of the assignment. It's our rule book. Over the course of 3 years, my students and I have encoded 37 months of strips. That's most of what we've read in the course. But since Peanuts ran from 1950 to 2000, we've only encoded 6.2% of the total. This summer, I was able to get support from my college to hire 3 of my students to continue working on the project with me. We decided to take on 3 tasks. First, we began encoding the strips from the 1991-92 volume. We've added another 15 months to the corpus, bringing our total, as of today, to 8.8%. Second, we decided to improve our data by proofreading those things that had already been encoded. This was necessary as we have changed our style guide considerably since the project began in 2020. I developed a proofreading workflow, and to date we've proofread 28 months, more than half of the total that's been transcribed. Third, we are beginning to work to report on the research, to draft an outline of an article of what we've learned by reading Peanuts so closely and also distantly. In the time I've got remaining, I'll briefly discuss 3 of our discoveries, each of which have been made possible by the data we have created. First, the question of character co-occurrence. You can see from this network graph that the world of Peanuts is smaller than you might think for a strip that ran for 50 years and had almost 18,000 individual strips. We found that the characters that co-occur most are Snoopy and Charlie Brown, and that's probably predictable. Linus and Lucy are up there as well. For now, I just want to point to the 4 nodes that are colored differently. We use Gephi's modularity algorithm on these data, and we were surprised, or in some ways not surprised, to find that the 4 characters who literally live across town, Peppermint Patty, Marcy Franklin, and Jose Peterson, do in fact exist in their own separate neighborhood as far as network analytics are concerned. And it's only co-occurrence in the strips that is influencing this model. So this is maybe not something we needed the model to tell us if you've read as many strips as we have at this point, but it's useful to see that the algorithms behind Gephi's community detection can make the same determination as readers who have access to all the information about the strip. What's more, these results have been confirmed through topic modeling, which I'll admit is maybe not the best way to prove anything. When running all of Peanuts through an 85 topic model this last semester, the topics in which Franklin and Marcy appear are clearly associated with Peppermint Patty, and none of the characters who live across town. Second, the question of stylometry. We wondered whether Schultz's characters spoke differently from one another. We have no evidence that this is something Schultz was trying to accomplish, but we were curious nonetheless. We used the Stylo package for R written by Maciej Ader, Jan Rybicki, and Mike Kestemont for our analysis. And since stylometry is sensitive to sample size, we only used identically sized chunks of text for characters that have 1,000 or more speech bubbles in the corpus. So this is the PCA for the 100 most frequent words displayed using a covariance matrix. There are a couple of things to note. First, Snoopy is on the far left side of the x-axis, and Violet and Patty are on the far right side. This suggests they're relatively distinct from one another. Second, Marcy sits at the top of the y-axis, clearly separated from all the other characters, again suggesting linguistic difference. Now, both of these observations can be explained by examining where the 100 most frequent words appear on the PCA. So here's the loadings for those terms. So again, Snoopy is on the far left, and the word that is most distinct in this space is the personal pronoun I. Violet and Patty are pulled to the right, where the word you is prominent. Also on the right are the words Charlie and Brown that literally sit right on top of each other. Snoopy's association with I is easy to understand. He's easily the most egocentric character in the strip, involved as he is in his fantasies. He uses this word, I, to such a degree that it marks his speech as different from the other characters. This also likely explains the presence of my on this side of the graph as well. Patty and Violet's association with you is a little more complicated, but it's helped by the overlapping Charlie Brown. What we think we see here is a pattern on the part of these characters to direct their dialogue toward others, particularly Charlie Brown. Often this is an accusatory way, detailing ways in which Charlie Brown failed or displeased them. Charlie Brown, you did this, you did that, so on and so forth. This pattern of behavior helps explain perhaps why Lucy, a character with a strong personality and stronger than either Violet or Patty, also tends to the right side of the PCA. She perhaps isn't pulled as far, however, because she has other roles to play in the strip than the sort of interchangeable female character that Violet and Patty are. As for Marcy, well, it's the word sir. Not surprising, but the model identifies it as a distinguishing aspect of her speech. No one in Peanuts, it turns out, talks like Marcy. We already knew that Marcy's an outlier, having read enough of the strip. Again, the model maybe doesn't tell us anything here. But the distinction between Snoopy and the girls provides us an angle we hadn't even thought to examine previously. Now, third, A third brief discovery. In understanding comics, Scott McCloud considers what happens between two panels of a comic and identifies 6 different types of transitions. He then measures the frequency of these transitions in a range of American, European, and Japanese comics artists. He even makes graphs. So it's, basically digital humanities. McCloud finds that there's a consistent distribution of transition types in most comics, especially among Americans. You'll notice a marked absence at both ends of the scale in these different graphs. When we graph our encoded transitions, we find that Schultz very much deviates from what McCloud observes. Peanuts uses the first type of transition, moment to moment, approximately 29% of the time. Other American comics artists don't use it at all, according to McCloud, or use it very, very rarely. What does this mean? Perhaps it points to the small scale of the dramas and indignities that Schultz so expertly chronicled in his strip. Or perhaps it points to the fact that McCloud's transitions are more appropriately applied to comic books rather than comic strips. It will take more research to know for sure. Whatever the case may be, we've also found transitions that simply do not work within McCloud's taxonomy. Consider the first in 5 September 1971. Schultz renders Linus as a computer in the first panel. But the transition between the first and second panels doesn't really make sense. There's a clear thematic tie to this doodle of Linus as a computer to the rest of the strip, so it doesn't count as a non sequitur. And it resists all of McCloud's other categories as well. While not all Sunday strips feature this sort of doodle, they happen enough that we've made them their own transition. And we found one other, where the transition is marked not so much by what the character does, but by how the camera zooms in between panels, in and out of a frame. Again, we don't know if this is a feature of Schultz or of comic strips more broadly, but we do know that McCloud's taxonomy is underpopulated. My time is short, so I'll make the conclusion direct. In their introduction to a special issue of Digital Humanities Quarterly on comics and the digital humanities, Roger Whitson and Anastasia Salter cite how frequently comics have been used to teach multimodal composition. And they point out that, quote, scholarship has yet to fully account for the remediation of comics as a digital form, end quote. Now, the work my students and I have been engaged in does not wrestle with the remediation of comics in a digital form at all. Instead, what we've been doing is exploring how comics can be used to teach digital humanities concepts, descriptive encoding, quantification of humanities objects, etc., and exploring how digital humanities methods can be used to teach close reading of comics. So much of the time, digital humanities works appears to be about reading distantly. What we don't say often enough is how it simultaneously helps us read closer than we ever have before. Thanks. And thanks to all of my students who have worked with me on this project over the past 3 years.